recall that we learned about exponents and logs last year. So we're gonna side note first, and then we're gonna come back to bell work because some of us might need a slight refresher over exponents and logs before we do our bell work. Okay. So can anybody tell me what a logarithm is?
No.
Okay, at least we're honest. Yes.
The inverse of an exponent.
Agreed. So remember, we talked about yesterday that our exponential functions are a function with a variable in the exponent. So we looked at some stuff that looks like y equals b to the x. Now, the problem arises is that if we needed to solve for x, right, we don't have any other operation that will get x out of the exponent. If it was like an x to the second and our power was 2, we can take the square root, okay? But you can't take a root with an index that's like an x to get the x out of it, okay? So that's where logarithms come into play. They are the inverse, or basically they undo exponentials. So they allow us to be able to solve for our exponents. And remember that those look like y equals log base b of x. So like our log and our x are like on one line, and then our b is like a subscript, so it's kind of like below those other two. So you read it as log base b of x. Now we can switch back and forth between our exponential and our logarithmic form. So our exponential form, like it kind of sounds like, has exponents in it. So we have something that looks like y equals b to the x, okay? And then for our logarithmic form, okay, so we're going to say logarithms equal exponents. So when we're rewriting from logarithmic form to exponential form, we want to use that to help guide us. Okay, so in other words, our base excuse me, of our exponential, excuse me, which is b, is our base of our logarithm. Okay, and we said that logarithms equal exponents. So what is our exponent in our logarithm or in our exponential form? X. So then that is what our logarithm has to equal. And then the y, or the other side, has to go inside of our logarithm. So notice that we said that the whole reason we like logarithms is because it gets our exponent, or our variable, out of our exponent. So here, my x is now out of my exponent. So if we needed to solve for x, you can rewrite in logarithmic form to get it out of the exponent. Now, can anybody remind me of our two special logarithms?
Log 2.
No, not two. There are buttons on our calculator.
1, 2, 3, 4, 6.
You're never gonna get there. You just count.
859.
No, it's not a number.
Oh.
Beta.
It is. Your natural log is one of them. Do we remember what that base is?
10.
Probably like 0.
It's not 10. Keep that in mind though.
Oh, yeah, well, I know of a 10 somewhere that is important.
10 to X.
Not a 10,
Oh.
but it's a letter
E.
E. So log base E of X is one of our special logs, and we rewrite it as the natural log of X. Okay? Then, like I said, there are two special logs. So our other one is our common log. We prefer in the future not come in the middle of my class, please.
I'm sorry.
So,
I just got here. It's just like
drop off. Thank you. Alright, so our common log, Connor, we think. What base did we say?
E.
No.
No, 10.
10. There
Yeah.
we go. So our common log is a base of 10. And we just don't write the base for that. So if you see something without a base, it's an understood 10.
Why?
Question.
Because it's common.
Because it happens a lot. So kind of like, with our square roots, right? We have other roots, right? A third root, a fourth root, and we have to write the little number. But with our square root, because we use square roots so often, we don't write the 2, right? It's just understood. Same thing here. We use our normal log or the common log so often that you don't want to have to write a 10 every single time you're using it. Yes.
So like on the log when it says E, is X the exponent of E?
No.
On the bottom part it's just like
It's
log EX.
No, it's log base E of X. So you would try to figure out E to what power gives you X.
Okay, so
Oh.
Remember, because we would look at, logarithms equal exponents, so you'd be saying your base of E to what power gives you X, or whatever's on the inside.
So the natural log and the common log are similar in that they are both actual logarithms, but they have
Special notation.
symbols.
Yeah.
Notations.
Yes.
Okay. So yeah, so like log E is log natural or ln.
Correct. Because it happens so often, we just use that notation instead.
Yeah, rewrite it to make it easier.
Yes. So we don't have to write log base. Yes.
So are we not supposed to use parentheses?
For what? You don't have to if it's just an X. If you have like X plus 2 or something and all of that is inside of the logarithm, then yes, you would put parentheses. But if it's just an X, it's not wrong to add parentheses, but you don't have to put it every single time. Yes.
What does the equal sign stand for on the natural log? Like the answer? Is that LN?
Yes, that is an L in X.
On the common log equals log X, is X a base or is it on the
Same line as your log. You don't have a base. So
Okay.
if it's a base of 10, then we just don't write the base. So
Okay.
anytime you don't see a base there, it's understood that it's a base of 10.
Well, so far I'm following, so I'm proud.
Other questions? Alright, so like we said, we have 2 different forms, so that means that we can switch back and forth between the 2. So if I'm given something in logarithmic form, there's a good hint because it says log in it, okay? That we want to switch it to exponential form. So our base of our logarithm is 2, so that's also our base of our exponential. And we said that logarithms equal what?
The exponents.
Exponents. Okay?
So it'd be 2 cubed.
Correct. So if my logarithm equals an exponent, my 3 is my exponent, and it's going to equal then whatever's on the inside, which is 8. So we have a true statement there because 2 to the third doesn't equal 8. Yes.
Isn't this where
Yes.
you like last year my teacher taught me like a little
Christ,
arrow
dude, I
trick.
remember that.
Yeah.
You
It,
Am I
yes.
gonna,
isn't
am
that
I gonna
why?
start doing good in this class or
Base
something?
or whatever.
Yes.
Dude,
I don't know it. I know what you're talking about. I don't teach it that way, but yes, I know.
dude,
Yes.
hell yeah.
Alright, so on this next one, what is our base?
4.
4. Okay. What is our exponent?
-4.
Equals 1/256.
Yeah, why do we end up with a fraction?
Because it's a negative exponent.
Because it's a negative exponent. And remember from yesterday that our negative exponents are going to give us fractions. So, and then 4 to the 4th is 256, which is why we end up with 1/256.
This class is so easy now.
Alright, we can also go the opposite direction. So notice this time we're in exponential form and they want us to write it in logarithmic form. So what my base of my exponent is going to be the base of our logarithm. And we said that logarithms equal what?
Exponents.
Exponent. So what is our exponent here? 3. And then our 3,375 is going to go in the middle. Okay? Now, on our next one, what does the 1/2 mean?
Just 1/2.
It's in
Not negative. Yep. So, a 1/2 or a 1/3 or a 1/4 turns it into a root. So a 1/2 would be the square root, which makes sense because the square root of 4 is 2. Yes. So that's just a reminder of what our fraction exponents mean. But they asked us to write it in logarithmic form, so we would have log base what? 4 of 2 equals 1/2. So now, hopefully, we can do our homework questions. So we're going to practice our exponential to logarithmic and logarithmic to exponential form using our bell work questions.
Done. I like sitting in front of the classroom.
Can I go put my water?
Good job, Kate.
Right.
This is very good. It's like a puzzle.
Really?
This is my hair sharp.
Alright, so on our first one, we should get 8 to the x power equals 73. On our second one, we should get x to the 9th power equals 54. Then on our third one, we have log base 2 of 32 equals 5. And then on our last one, we have log base 9 of 88 equals x.